All right, so looking at our enthalpy, ways to quantify enthalpy so far, we have phase changes over here. We have reaction enthalpy over here, and we're going to add a third one here. But before we get into it, we need to talk about heat. And so the difference between heat and temperature can be summed up really nicely by this video link, and I'm going to put it in the description below. And it's a cartoon, it's really good, geared towards kids, but I still watch it and still love it every time. It's really cool. Watch the video, make sure you know the difference, and then from there we'll talk about heat energy adding to something, right? So if heat energy is added, the temperature will increase, and so let's say that we have this mass and we want to increase the temperature. And so we need to actually put energy onto it. So we have a couple of variables when we look at these things. So we have mass of the object. We have the amount of heat added. So that's going to be heat, which is called Q. Right? So Q is the heat. The nature of the substance is called C, and that's the specific heat capacity. And so the specific heat capacity by definition, and you can tell this from the units, is that the amount of energy in joules that is needed to raise 1 gram of water or 1 gram of the substance 1 single degree Celsius. Now you can also see this as kilojoules per kilogram degrees Celsius, and I find that if you're already working with big quantities, you can use this one, or you can stay with joules and grams otherwise. Now you'll also find something called delta T, or the change in temperature, and that's just exactly that. So that's change in temp. Now, you can see on the bottom right hand here in table 6.1 that there's lots of different heat capacities for different things. So even liquid water and solid water or ice are going to have 2 different heat capacities. Now, when are we going to actually use such a formula? Now, we could use this formula when we're dealing with a change within a single phase. Now, so here we'll use Q equals mc delta T when we change temperature, but not state. So change temperature, not state. Right, and so that would be the final bit in our ways to quantify enthalpy, right? So we have phase changes, we have chemical reactions, and we have the change in temperature, the change in heat that's applied to an object. Now, when we're looking at the chart over on the left, you'll see some dips and valleys. Now, these are where we see phase changes. If you see a stop on a graph with temperature on the left, and you see that it stops around here from point B to C, this would be a phase change, and here you'd have to calculate the enthalpy from the formula for phase changes. But on these slopes, you'll actually need to use Q is equal to mc delta T, because that's within a phase. Now, if you have parts 1, parts 2, parts 3, and parts 4, all of those enthalpies together, 1 plus 2 plus 3 plus 4 is equal to the total enthalpy change. So it's the total enthalpy, change in enthalpy for the entire question. All right, so you're going from 2 different changes of state. This will happen a lot with a question about water that you might see in class, and I challenge you to know what you know already and tackle one of those before seeing it done for yourself.